Everyone, I hope you all will be fine, safe and healthy at your home, and I hope you all will be enjoying your online classes. So let us start our today's session without wasting our time. In our today's session, I have brought the study of lattice enthalpy. So first of all, you just have to see what I have written about the lattice enthalpy. So you see here, lattice enthalpy, Le denotes to the lattice enthalpy of ionic compound is the enthalpy change which occurs when 1 mole of an ionic compound dissociates into its ions in gaseous form. Okay, suppose KCl it is to be there. When it will dissociate, so it will dissociate into K positive and Cl negative. But here we have to know its ions should be dissociate into the gaseous form. So for that, the amount of energy which is to be used, this is to be of lattice energy, or we can call it this is lattice enthalpy. So here we have to study about the Born-Haber cycle, where we will specifically this cycle is to be used to determine the lattice enthalpy in terms of different ionic compounds. So here I have brought the example of sodium chloride. This is NaCl. So you see here what I have written. Let us consider NaCl, and we know that in NaCl, Na positive, sodium will be cation and Cl will be of anion. So in first step, first you have to see sodium that occurs in a solid form. So when it will convert into a gaseous form, so we need to convert solid into gas. We have to sublime it. Okay, so the energy we needed, this is the sublimation energy, and the amount of that energy, that is equal to 108.4 kilojoule per mole. Okay, now in the step 2, sodium that is in a gaseous form, now we have to convert into a ionic form. So it is in a gaseous form, and as we have to convert into a cation, so it means we have to release the electron from its valence shell. So as you all know that the amount of energy which is required to remove the electron from outermost shell of an element, this is of ionization energy. So as we are converting into ions, so the amount of energy which is to be used, this is of enthalpy of ionization, and that amount it is to be of 496.0 kilojoule per mole. Let's talk about the third step. Here we have taken half moles of chlorine, and that is going to convert into chlorine gas. So here that atomization, this molecule we are converting into a single atom. So enthalpy of atomization is to be required, and the amount of that energy, this is of 121.0 kilojoule per mole. Let's talk about the step 4. Chlorine that is present in a gaseous form, and we have to convert into a anionic gaseous form. So it means that will accept 1 electron. Okay, so because it is gaining 1 electron to convert into a Cl1 negative ion in a gaseous form, so that energy it is to be known as electron gain enthalpy. Here I am telling once again, because it is gaining 1 electron in a gaseous form, so this is of electron gain enthalpy, and the amount of that enthalpy it is to be of negative 348.6 kilojoule per mole. So here we have to understand, for step 5, Na cation in a gaseous form, Cl anion in a gaseous form, they both will link together and they will form NaCl, that will be in a solid form. So this is the enthalpy of formation, and that amount it is to be of 411.2 kilojoule per mole. Okay, so here you have to see what I have written. The sequence of step 1 to 4, whatever the step I have explained, this sequence from first step to the 5th step is known as Born-Haber cycle. Okay, so the special note which I have written, you have to see the sum of enthalpy change around the cycle is 0. Okay, so lattice enthalpy, it is the sum of the enthalpy of all the steps, step 5, 1, 2nd, 3rd and 4th. So all the energy that I have showed in the different step, that we have to take the sum. So the lattice enthalpy that will come after addition of all these enthalpies, so that comes positive 788 kilojoule. Okay, so here the important point which is understandable, internal energy is smaller by 2 RT. Okay, if we are taking delta Ng, 2 numbers of moles of gases, so this is of 2, and which is equal to near about 783 kilojoule per mole if we will solve it. Okay, so now here you have to understand the one more point. So now we use the enthalpy to calculate the enthalpy of solution from this expression. Means we will use here the enthalpy of hydration, because whenever we dissolve NaCl in the water, so we have to use there the hydration enthalpy that relates to the solution. Okay, so for the solution, lattice enthalpy of NaCl that we have got it 788 kilojoule per mole, and hydration enthalpy, this is of 784 kilojoule per mole. So 88 minus 84 we will get plus 4 kilojoule per mole. So that value is to be very less. So dissociation of NaCl is accompanied by the very little heat energy. Okay, so that is only the reason whenever we put a pinch of NaCl in the water, it easily dissolve in the water. Okay, because its enthalpy, lattice enthalpy is very less. Okay, so I hope you all have got this. What is the Born-Haber cycle? That's all for today's session.